Hello, algebra students. Mr. Lawrence here, and we are going to do two quick problems. I was a little surprised at some of the difficulty we were having with some of these, particularly in my one class. My other class seemed to have them mastered pretty well. But be that as the case, I do think both classes are working hard, so I don't mind taking a step back to help you get caught up. First thing I'm going to do is I'm going to look for negative exponents, right? Because a negative exponent means to use the reciprocal. And I'm going to highlight all the terms that have a negative exponent. Oops, there we go. Okay, all those terms will have a negative exponent. Pardon me 1 second, I forgot to put something in the problem. Ooh, I'm having some serious lag going on here. There we go. Okay, getting back to this problem here. I am going to rewrite this problem with positive exponents. I'm going to have 15 over 25. Now the x to the negative third will go to the denominator, right? As an x to the positive third, because the negative exponent means use the reciprocal. And an x to the negative fourth will go to the numerator as an x to the positive fourth. I'll have a y to the fourth in the numerator. This y to the negative first will also go to the numerator and become a y to the first. And then I'll have z to the eighth over z to the 10th. Now, some of you might have said, hey, Mr. Lawrence, I'd like to simplify some of those. Well, absolutely, I'm going to. And if you simplify now, that's perfectly fine. You could have simplified as you want. So I'm going to do 15/25, which I think is going to be 3/5, right? That doesn't look like a 5. Let me rewrite that. There we go. Okay, my x is x to the fourth over x cubed. Well, doesn't that mean over, and then those will cancel, right? That'll give me an x in my numerator. My y's, I'm going to have a y to the fifth in my numerator. And I'm going to have z to the eighth over z to the 10th. Wouldn't that leave a z squared in my denominator? All my exponents are positive. I only have one variable of each type in the fraction, x in the numerator, a y to the fifth in the numerator, and then a z squared. For example, I don't have x's in both the numerator and denominator. Okay, so now I'm going to have 3, and I'm going to substitute in for x, and I'm going to substitute in for y, and that'll be over 5, and I'm going to substitute in for z. So, x is -2, y is -1, and z is +1. So I'm going to simplify things as best I can. I know that this is going to turn into -1. -1 to the fifth power will be -1. I'm going to have 3 times -2 times -1. It's going to be a positive answer, and it should be a 6. In my denominator, I'm going to have 1 squared, which is 1, times 5, which is 5. My answer is 6/5. Pretty easy stuff. Now, if you have any questions about that, I expect you to be coming and seeing me or asking me. All right, let's do one more quick example. Let me get a highlighter here. All right, I've got an x to the negative third. He's going to need the reciprocal, and a y to the negative second, going to need a reciprocal for him. And I also have this -2 out here. Now, I did him in a different color. Just ask Zach. He'll tell you it's because it's a little bit different than what's going on inside the parentheses. He's outside the parentheses, so I'm going to leave him a different color to highlight. And I'm going to rewrite my fraction. Now, by the way, some of you want to simplify as we go. I'm going to simplify 20/30 to 2/3. I'm going to have an x cubed move downstairs, and there's already an x down there. A y squared is going to move upstairs. There's already a y up there. And then my z to the 10th over z to the 9th will give me a z in the numerator. Now, this is not simplified completely inside the quantity. So I'm still going to have to simplify a little bit more. And then I will deal with that highlighted green exponent. So I have a quantity of 2y cubed z, and that'll be over 3x to the fourth. And there's a -2. Okay, now remember, a negative exponent means to use the reciprocal. So, like Tommy Call can tell you, all I'm going to do is flip this fraction. I'm going to get 3x to the fourth over 2y cubed z. That's going to be raised to the second power. Now, at this point, I would like to substitute in and then square my answer. But some of you don't like that, so I'm going to go ahead and square everything. 3 squared is going to be 9. X to the fourth squared is going to be x to the eighth. Denominator, I'll have 2 squared, which is 4, y cubed squared, which is y to the sixth, and z squared, which is z squared. At this point, I'm ready to substitute. I'll have 9 times that, and I'm going to put some numbers in. X is going to be negative 2. Y is going to be 2. And z is negative 1. All right. Got to follow the order of operations here. I'm going to have 9 times, 1 second, ladies and gentlemen. Sorry about that interruption. I had some students that needed my attention. Well, let me see. 2 to the 8th. That's really not that hard of a problem. First of all, I know negative 2. When I multiply 8 negative 2's together, all the negatives are going to cancel. So my answer is going to be positive. But I know 2 to the first is 2, and 2 to the second is 4, and then 8, and then 16, and 32. That's 5. 2 to the fifth. 2 to the sixth will be 64. 2 to the seventh will be 128. 2 to the eighth will be 256. So I'm going to have 9 times 256. I'm not going to multiply that yet. You'll see why in a second. Now I'm going to have a 4 in my denominator. And I'm going to have a 2 to the sixth. Well, that's going to be 32. Okay. And then a negative 1 squared is going to be negative 1. Now, it's going to be positive 1, excuse me. Let's just back up a second here. And this 256 was the same as 9 times 2 to the 8th power, right? So isn't it like 9 times 2 times 2 times 2 times 2? There's 4, 5, 6, 7, and 8. I actually was kind of foolish to multiply it all out. Watch what's going to happen. Now there's 32. Oh, that should be 64. Excuse me. 64. But that's really 2 times 2, 3, 4, 5, 6. And then times a positive 1. Because this is all multiplication and there's a fraction, I can do some canceling out. These 2's can cancel, those 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 2 can cancel. I know something else can cancel. 2 times 2 is 4, and there's a 4 in the denominator. This simplifies to 9. If you don't believe me, check it on a calculator. It should work. Yeah, the 256 part should cancel out. 9 over 1, which is just simply plain old 9. Very simple stuff. Gotta get comfortable with those fractions. All right, so let's recap really quick. The first thing we did was to simplify the fraction as much as possible. Move any terms with negative exponents, use their reciprocals so they have positive exponents. Combine or eliminate, cross out terms like x's and y's, things like that. And then once the fraction was completely simplified, then we put our numbers in for x. Okay, yeah, I think that's it. That's all I'm willing to do. We're going to get a little practice with this in class tomorrow. Mr. Lawrence signing off. Have a good night, everybody.